as Claudine Sierra said, water used to be fresh, pure, and drinkable. Now water has lots of fecal matter and bacteria. Ladies and gentlemen, my name is Hussein Saidi, and my name is Hassan Saidi. Students from Beirut International School, Maputo, Mozambique. And what brings us here today is the effect of fertilizer on water quality of crops over time. It is known that many people use fertilizers for commercial use, but are unaware of its harmful impacts. The main two ingredients in fertilizers are phosphorus and nitrogen, which are present in fertilizers through compounds such as ammonium phosphate and nitrate. Excess nitrates are as dangerous as high nitrate levels in drinking water can cause infants to develop illnesses such as methemoglobinemia, a disorder which interferes with oxygen intake in the circulatory system. And in this experiment, we studied the effect of fertilizers on water quality of Butu Creek over time. Millions of people use fertilizer in their farms and backyards to increase their crop yield and enhance the growth of their plants. However, the improper use of fertilizer combined with runoff can contaminate the groundwater of streams and lakes and degrade their water quality. Nutrients in fertilizers can cause nutrient buildups in streams, lakes, rivers, stimulating unwanted growth of algae. Furthermore, the nutrient enrichment could lead to reduced dissolved oxygen concentrations. Without sufficient dissolved oxygen, fish and other aquatic species will suffocate. Fertilizer is primarily made up of two nutrients, such as nitrogen and phosphorus. Although phosphorus is mainly responsible for other blooms in saline water and can cause an excess amount of nutrients, its low solubility renders the loss of phosphate in water significant, especially in comparison to quantities released by industrial waste. On the other hand, nitrogen is highly soluble and can leach down through soil, contaminating the groundwater. Moving on to the methods. 812 water samples were stored in a house at room temperature over a period of 4 days to study the effect of fertilizers on water quality. The 812 water samples were collected using measuring cups in identical mason jars, which were then taken to the lab to the house and labeled. TDS, pH, and nitrate levels in each of the jars were measured using a total dissolved meter, pH meter, and nutrient strips. Nutrient strips measures nitrate, alkalinity, hardness, pH, nitrite, chlorine, etc. But for this experiment, only nitrate was recorded. Regarding the fertilizer distribution, 3 different fertilizer treatments would be applied to 6 jars, each of with 0.5 tsp, 1 tsp, and 1.5 tsp that replicate and result in a fertilizer concentration. This experiment was conducted to study the effect of fertilizers on water quality. Data was collected by measuring the changes in TDS, pH, and nitrate levels of water from a Butu Creek over a period of 4 days to study the effect of fertilizers on water quality after the addition of 2 treatments of 0.5 tsp, 1 tsp, and 1.5 tsp. Each treatment were applied to 2 samples, and there were 2 samples that were given no fertilizer that acted as control samples for this experiment. Bar graphs and one-way number tests were used to compare the effect of fertilizer dosage on the concentrations of TDS, pH, and nitrate levels, shown in figure 1A, 1B, and 1C. The ANOVA test demonstrated that there was significant effect on all 3 indicators. In TDS and pH, P was less than 0.00001, and in nitrate, P was equal to 0.00305. Linear regression tests also revealed that there was a moderately strong and positive relationship between time and TDS, shown in figure 2A and table 1. On the 4th day, no value was recorded because the number had exceeded the maximum limit of 9,990 parts per million in TDS meter. Time versus pH, time versus nitrate. They both have a good relationship, shown in figure 2B, 2C, and table 1. On the 2nd day, the nitrate levels had spiked, and all 3 indicators had increased by 10 parts per million and gradually returned to the original levels on the 4th day, shown in figure 2C. We hypothesized that as the amount of fertilizers on Maputo Creek increased, the water quality would decrease. A drastic increase in TDS and nitrate levels and also decrease in pH after fertilizer was added supported our hypothesis. TDS and nitrate levels exceeded the US guidelines of 500 parts per million and 10 parts per million respectively, while the pH dropped below the acceptable range of 6.5 to 8.5, listed in the secondary maximum contaminant level for pH. In a period of 4 days, TDS levels for all treatments with the given samples 1.5 exceeded 500 5,990 parts per million is shown in figure 2A. TDS is the total concentration of dissolved ions. Therefore, it makes sense that TDS increased after soluble fertilizer soaked with water, which adds first dissolved ion. TDS is the total concentration of dissolved ions, but we expect that the experiment will conclude after 4 days, and that TDS will have continued to climb if measured for a long duration, highlighting the negative impact that fertilizers has on water quality. In order to determine the fertilizer's effect on water quality, TDS, pH, and nitrate levels for all different treatments were recorded in a Google spreadsheet. We use a timeline regression and a scatter plot to display the R2 values to study the effect that time had on individual treatments.
As a result, it revealed that continued use of fertilizer degrades the water quality of creeks, rendering it dangerous for human consumption. Therefore, we suggest that we should limit the fertilizer used to protect the environment and their peer. Thank you.